Hey, 8th graders, today's lesson is 3.3 and 3.4, Force in Motion. This is our last Amplify lesson for this unit. Your learning targets for today: I can describe the forces each object put on another in a collision. So remember in our last lesson, 3.1, 3.2, we learned that when two objects collide, again, we're focusing on two objects now versus just one, which is what we've looked at in the first two chapters. But when two objects collide, no matter the size of those objects, they're going to put an equal force on each other, but in an opposite direction. Okay, so I think the survey question that we had asked was if a bug hits a windshield. Obviously, the car with the windshield is a higher mass. The bug is a much smaller mass. And even though they have such different masses and have such different effects that happen after that collision, okay, that bug and that car are going to put the exact same force on each other. And you guys really dug into this in the 3.1, 3.2 sim. And you saw no matter what collision you made, those pink arrows were always equal but pointed in opposite directions. Okay, and your second learning target: I can predict how the motion of objects will change after a collision. Here's the thing that you guys really need to remember. We know that objects put forces on each other when they come into contact because we can generally see some sort of change of velocity in those objects. And we only get those changes in velocity or changes in motion if a force is exerted on them. So if we have two pucks that run into each other and puck B is really, really heavy, but puck A is really, really light and puck A is crashing into puck B, we know that they put an equal and opposite force because we should see roughly about the same change of velocity depending on the mass. If the mass is the same, we'll see the same change of velocity, but if the mass is different, we'll see some change in motion, and that's how we know that there's a force put on them. Okay, remember that you can't see force, you can only see the after effects or the change in velocity of those objects after the collision. Okay, so moving on to your guys' notes for today, you're going to add key concept 7 to your key concepts page of your OneNote. Even though the force exerted on each object in a collision is the same strength, if the objects have different masses, their changes in velocity will be different. Okay, so again, this is going to tie us into the ACM pod and the space station. We know that the ACM pod was heavier than normal. When the thrusters fired, it only slowed it down. The pod kept moving and eventually crashed into the space station. And what we found out in 3.1, 3.2 was that the space station moved a little bit, okay, but the pod turned around and bounced off and moved in the opposite direction. Okay, so today we're going to take a look at how mass plays into this scenario. Okay, for your guys' bell ringer of the day: prediction in a collision, how do forces affect objects? I predict that, so you guys should use your draw tool to circle that both objects should and will change velocity. Only one object should change velocity, or neither object should change velocity. Okay, so use the force in motion simulation to gather evidence about how forces affect the objects in a collision. So as you can guess, you guys are going to open up your sim link and you're going to test this prediction that you just made. So scroll down to 3.3 warm up. Okay, we've got a heavy object. Okay, this is about 4 kilograms. Okay, it is moving at 5 centimeters per second to the right. And then we've got a 1 kilogram object. Object B is at rest. So if we click on the velocity is 0. Okay, so record the mass of each object, run the test collisions, change the starting velocity of each object as described in your data table. So on the next slide, we have our data table. Our first set of velocities is going to be how it's set up when we open up that part of the link for the 3.3 warm up. Okay, so then you're going to go ahead, take a look at the change in velocity. So again, A is our heavier object. So we're going to let them collide, and then we're going to go to analyze. And I'm going to pull this guy down here. All right, so if we look at object A, it started out moving 5 centimeters per second to the right. After the collision, it was only moving 3 centimeters per second to the right. So it changed by 2 centimeters per second. So change in velocity for object A was 2 centimeters per second. Okay, change in velocity of object B. If we take a look at B, it was at rest. Now it's moving 8. So we had a change of 8, which is significantly higher than our object A. Okay, you guys are going to set up the exact same scenario, but we're going to go back to build, and this time we're going to make B move towards A, moving 2 centimeters per second, so they'll collide, and then you'll collect the data there, and then at the end, this one, you guys are going to make the B puck go 2 centimeters per second in the opposite way. So obviously this one's moving faster, it's going to catch up to this puck. So go ahead, pause this video, take a second to finish up this sim, and fill out this data table, and then answer these questions on the next couple slides. So in a collision, how do forces affect object? This is the same prediction question, so just kind of solidify your prediction. Were you right or wrong? What did you come up with after the sim? And why do you think the objects in each collision experienced a different change in velocity? So again, pause this video, finish up through slide 7, and when you guys are done, come on back to the video. All right, moving on to activity 3, you guys have a little article to read called Crash. So again, chapter 3, our focus is collision. So your article looks like this. You guys can see the little bug that we were waiting on, about ready to hit the windshield. So you guys are gonna learn a little bit about a couple different collisions that you guys might see: pool balls, bumper cars, obviously the bug and the windshield. Okay, so read through that and then you will answer these 2 questions. What are the effects of the collision forces when objects with different masses collide? So we obviously know that they experience a force when they collide. So what happens after the force? Okay, the cause is the force. The effect is going to be the change in motion afterwards. So answer that question. Make sure you guys use your own words and aren't just copying and pasting from the article. And then what are the effects of the collision forces when objects of the same mass collide? So again, your force of your collision is your cause. Your change in motion after the collision is going to be your effect. So when we see 2 objects of the same mass collide, what might you see with the effects there? Okay, again, take a second, pause this video, come on back when you are done, and we'll move on to the next section. Oh boy, we've got Sherman here, and Sherman's probably got another story to tell us. So, did you see that? When the ball crashed into the pins, those lightweight pins went flying, but the heavy ball barely changed its speed. Yeah, the ball must have exerted a really strong force on the pins, but the pins didn't exert much of a force on the ball. Okay, sorry, Sherman, but a pin exerts the same force on the ball that the ball exerts on a pin. It's a collision. Huh? Don't the forces have to be different to cause such different effects? Actually, Sherman, the forces in a collision are equal. The effects are different because, and again, we know that there's a force because we see some change in motion between the ball and the pins. Okay, so how do we know the forces are equal when we see such different changes in the motion? So how would you finish the explanation to Sherman? Why do colliding objects of unequal mass experience different effects? So again, think of the bowling balls and the pins. They have very different masses. Okay, all right, so go ahead, complete side 9s and 10. When you're done, come on back to this video and we'll move on to our last little section here. All right, so some more information that we need to know moving forward with our talk about the asteroid collection pod and the space station. So in case you might find the following helpful for comparing the speed of the pod and the space station after the collision, here are their masses. So we know the pod is weighing a little bit heavier than normal, and this mass of this pod ended up being 1,100 kilograms. Again, remember that's a little heavier than normal because we had a little bit more asteroids collected this time, versus the space station is 415,400 kilograms. So I'd say a little bit bigger. Okay, so using that information, you guys are going to look at these 3 claims. Remember that the pod came in at a medium speed and the thrusters exerted a medium-sized force in the opposite direction, but because the pod was slightly heavier than usual, the pod did not stop like it was supposed to. It did slow down to a small velocity, but eventually collided with the space station. So right before it hit the space station, it was going a small velocity, whereas before the thruster force, it was just going a medium velocity. So we're actually seeing 2 forces here. We're seeing the first force from the thrusters on the single object, the single pod, and then after that didn't stop it, then we're gonna see the force of the collision and what happens after that. Okay, so circle the claim you think describes the motion of the pod and space station after their collision. So claim 1, again, use your draw tool for this. The pod is moving faster than the space station. Claim 2, the pod and the space station are moving at the same speed. Or claim 3, the pod is moving more slowly than the space station. So circle your correct claim there. And then if the pod has a mass of 1,100 kilograms and the space station has a mass of 415,400 kilograms, what does the movement of the pod look like after its collision? Explain why. So what do you think the pod is doing after it hits the space station? You guys should already have a pretty idea. We've known this since the very, very beginning. Okay, how about the space station though? If the pod has a mass of 1,100 kilograms and the space station has a mass of 415,400 kilograms, what does the movement of the space station look like after its collision? So now, the space station we haven't talked about yet. We just found out it's moving. What does that movement look like? Again, this is how we know that even though the pod's smaller, it still put a force on the space station. Okay, and obviously because the pod turned around and moved in the opposite direction, we know that the space station put a force back on the pot as well. Okay, and those two movements should be equal, or change in motion shouldn't be equal, because we obviously don't have equal masses. So kind of use that to help you guys explain why. Okay, once you guys are done with that, go ahead, do your exit ticket, and let me know if you guys have any questions. If not, I will talk to you soon. Have a great day. Bye.